Types of matrices. There are various types of matrices, depending on their structure. In this video, you will learn about the different types of matrices. Thanks for watching this video, and don't forget to like, subscribe to the channel and activate the notifications. It's very important to the continuity of this channel. There are certain types of matrices whose special properties allow them to play an important role in matrix algebra. It's time for you to make their acquaintance. A row matrix is a matrix with only one row. Matrix A is a row matrix of order 1 by 3. In general, we write a row matrix as follows. A column matrix is a matrix with only one column. Matrix B is a column matrix of order 2 by 1. In general, we write a column matrix as follows. A matrix in which the number of rows are equal to the number of columns is said to be a square matrix. Thus, an m by n matrix is said to be a square matrix if m equals n, and it's known as a square matrix of order n. Matrix C is a square matrix of order 2, and matrix D is a square matrix of order 3. In general, we write a square matrix as follows. The main diagonal of a square matrix is the ordered set of elements aij for which I equals j extending from the upper left-hand corner to the lower right-hand corner of the matrix. Thus, the main diagonal contains elements a11, a22, a33, etc. The elements of the main diagonal of C are 1 and 3. The elements of the main diagonal of D are 5, 7, and 0. A diagonal matrix has all its elements 0 except for those in the main diagonal. In general, we write a diagonal matrix as follows. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. The matrix A is a scalar matrix of order 3. In general, we write a scalar matrix as follows. A unity matrix is a scalar matrix in which each diagonal element is 1. A unity matrix is denoted by I. A unity matrix of order n is denoted by I sub n. The unity matrix is also called identity matrix. The first unity matrix has order 2, and the second unity matrix has order 3. In general, we write a unity matrix as follows. The unity matrix plays an important role in matrix multiplication. Let us check to see what happens when we multiply the matrix A by unity matrix of order 2. When we multiply matrix A by the unity matrix, doesn't change anything. We get back the same matrix. The unity matrix plays a similar role in operations with matrices as the number 1 plays in operations with real numbers. A real number remains unchanged when it's multiplied by 1. A matrix remains unchanged when it's multiplied by the unity matrix, regardless of the order in which the multiplication was performed. If we multiply any square matrix by the appropriate unity matrix, we get the same initial matrix. The transpose of a matrix is another matrix that is formed by switching its rows with its columns. Look at the example. The symbol is a T placed above and to the right. In general, we write the transpose of a matrix as follows. If the transpose of a matrix is equal to itself, that matrix is said to be symmetric. Look at the example. Matrix A is a symmetric matrix. Pay attention to the main diagonal and you will notice the symmetry. In general, we write the symmetric matrix as follows. A matrix in which each element is zero is called a null or zero matrix. Zero matrices are generally denoted by the symbol O.